Hello friends, I am Assistant Professor Raut Vaishali Sanjay, Department of Chemistry, KVN Naik College, Nasik. Welcome to my YouTube video. Today we shall be talking about gas chromatography. Gas chromatography means what? Chromatography is a technique of separation, analysis and identification. Chroma is color, graphy is for writing. In the gas chromatography, actually we do not see different colors, but separation is definitely done. We are going to discuss about the mobile phase and the stationary phase in the chromatography, a gas chromatograph, a carrier gas supply, the sample injection system, and about the various detection systems in gas chromatography. Let us see what is meant by gas chromatography. It is a common type of chromatography that is used in analytical chemistry for separating and analyzing the compounds which can be vaporized without decomposition or such compounds which are already present in the form of a gas. So it is very important that we require a sample which is gaseous in nature. Now if we have a sample which is gaseous in the nature, then for shifting it off, that is for taking it forward, we are going to require a mobile phase which is generally gaseous in the nature. So we will require a mobile phase which is inert, that is which does not react with the sample. The mobile phase therefore is gas. The stationary phase, it can either be solid or it can be liquid. When the stationary phase used is solid, it is called as gas solid chromatography, and when the stationary phase is liquid, it is called as gas liquid chromatography. Gas chromatography is a combination of partition and adsorption chromatography. So let us go and find out what is a device that is used for gas chromatography. A device that is used for the purpose of gas chromatography is called as gas chromatograph. This gas chromatograph consists of a carrier gas cylinder, flow controller, then a column oven in which the column is placed. Obviously we are going to place the column in the oven. Why? Because we require the gaseous samples or those samples which can be vaporized at the column temperature. Then this column is connected to detector, and the detectors are in turn connected to recorders. Let us study the importance of what are the carrier gases that are used in gas chromatography. The carrier gases, as we have discussed, should not react with the sample, so they must be chemically inert. So generally chemically inert elements that are helium, nitrogen and sometimes hydrogen are used as carrier gases. In addition to these carrier gas system, it is supplied with the pressure regulator, gauges and flow meter, so that the speed of this gas, carrier gas, can be controlled. If the speed of the carrier gas is very high, then it will not produce efficient separation or we will not get good peaks. But if the speed of the carrier gas is very slow, then there will be tailing after the peak. In addition to this, even the carrier gas system is provided with molecular sieve to remove water or any other impurities in the system. The carrier, after this we have a column. In the column, the sample has to be injected. The sample that is required for the gas chromatography is very small amount. This small amount of sample is either in the form of a liquid which can be converted into gas, or it is a gas itself. So it is filled in the small syringe called as micro syringe. This micro syringe is inserted into the sample injection system. The sample injection system has the self-sealing septum. Self-sealing means After the injection, there is a creation of small hole. When the syringe is removed, the hole is again sealed back. The column configuration, either there are 2-3 types of columns used, packed or open tubular or the capillary columns. The larger the size of the columns, better is the separation, and hence the columns are kept in the form of a coil in the oven. The columns are of the length of about 2 meters to 50 meters and the diameter of the column is about 10 to 30 meters. The column temperature. The column temperature is kept in such a way that the sample that is injected in the sample should remain in the vapor form without decomposition. Generally, the temperatures above the boiling point above the boiling point of the sample are selected. The detection systems in the column chromatography. The ideal detector for gas chromatograph should have adequate sensitivity, it should have a good stability, it should give us reproducible result, it should give us linear response to the solute, and it should extend over several order of magnitude. A temperature should range from room temperature up to 400 degrees Celsius. A short response time, that is, it should be independent of the flow rate of the gas. It should be highly reliable and easy to use. Similarity in the response for all the type of solutes. Otherwise, if it gives a different response to the different solutes, then it will become particular for a given solute only. That is not good, and hence it should give a same response to all type of solutes. It should be highly selective for one or more classes of solutes. So various detectors are used. The choice of the detector depends upon the physico-chemical properties of the analyte. It amplifies the response and converts it into electronic signal and also produces the data system for a chromatograph. Different type of detectors are used for different type of sample. The favorite ones are flame ionization detector, that is FID, which is generally used for hydrocarbons. Electron capture detectors are for those compounds which contains electronegative elements. Thermal conductivity detectors are universal, that is, they can be used for all the types of compounds. Mass spectrometers are tunable for any species. Then FTIR, that is used for organic compound. Photoionization detectors are for those compounds which can be ionized by UV radiation. Thank you.